Linacs technologies.
Hello and welcome to a new Simac demo, where we use Simac, the linac simulator, to learn and teach linac troubleshooting, maintenance, and operational procedures. In the previous episode we used Simac to replicate results published in a research paper. We showed how beam energy changes and the depth dose correlate with unflatness. You can find the link to that video in the description below. In this episode, we will do a similar experiment, but we'll examine how changes to the beam energy correlate with flatness changes in a regular beam that use a flattening filter to create a uniform beam profile. We will cover energy ranges from 5.8 MeV to 6.2 MeV. To do this experiment, we will adjust the electron beam energy by changing the gun grid voltage, and will match the beam energy and bending magnet pass-through energy by changing the bending magnet current. Let's verify that the cross-plane and in-plane profiles are flat for 6 MV. To do this, we pick the default operating point for 6 MV, and run a simulation. Let's go to the Treatment Head tab and look at the profiles. Perfect, at Dmax our profiles are flat. Now we can change the energy of the beam and observe how the profiles change. Let's go to the main Simac tab, and modify the bending magnet current and gun grid voltage. To make a 5.8 MeV beam, we start from 16.13 amps current and 119.82 volts grid voltage. Now let's run a simulation. We can see that the beam energy and bending magnet pass-through energy match. Great! Let's check also the profiles. As expected, because we have 5.8 MeV beam energy, but used flattening filter for a 6 MeV beam, the flatness of the profile got worse. Let's save this machine state, to be able to run a water tank experiment with it. I'll name it 5.8FF. Now let's repeat this process for other beam energies, up to 6.2 MeV. Now that we have all the machine states that we are interested in saved, let's run water tank experiments on each beam. We start by labeling the experiment, and choosing the machine state. For cross-plane profiles, we need to specify the depth at which the scan is performed. For 6 MV beams, the Dmax should be at around 1.5 cm depth. Now we can repeat for the other saved machine states. Great, now let's compare the profiles by going to the Compare tab. We can see the flatness values of the profiles changes with the beam energy change. Thus, a flatness value can be used to monitor the changes in beam energy. Contrary to this, when looking at the depth dose scans, we see that there isn't that much of a change in Dmax or dose at 10 cm depth when beam energy changes. Here we go. We used Simac to do an experiment to study how profile flatness can be used as a troubleshooting metric for beam energy changes. Doing so on a real machine would have consumed a lot of time, but we did it in a virtual environment. This is just a start of the results you can learn, teach, and replicate on Simac. To get started with Simac, create a free account at linacs.ca to start your journey to mastering everything about linear accelerators. Thank you for joining this Simac demo. See you at the next one. Don't forget, your always free Linacs account gets you 5 Simac runs per day. Go to linacs.ca to get started.